Software projects change all the time. And I can guarantee you that in your time as a software engineer, you are going to have to do system migrations. Sometimes you can't plan ahead for these types of migrations, but I would like to provide some tips and pointers on what you can do to mitigate the negative impacts of these big migrations while still gaining the positives of actually doing the migrations. What do I mean by a system migration? I mean anytime you have to change a major portion of your code base to replace an underlying system. For example, let's say your company decided that the logging system it's using to aggregate logs is too expensive and it needs to migrate to using a new one. You would have to go through all of your code to make sure to remove the old API and replace it with the new API. That's what I mean by system migration. Mitigating the negative effects of massive migrations starts in the planning phase. I don't mean the planning phase of the migration. I mean the planning phase of your system design. That's right, you need to build your system with migrations in mind. Every application, service, or serverless function interacts with other parts of your system. It is your job to identify the interfaces where these applications, servers, or serverless functions actually do the interaction with those parts of your system. You want to isolate those and protect them so that if that interface were to change, the rest of your code isn't affected. Alright, so let's take the logging system example that I used earlier and see how this can mitigate the migration problems. Okay? If my company used a service to aggregate logs, let's call it Samurai Logic, I would interact with Samurai through the Samurai API. Then, as I sprinkle the logs all over my service, everywhere that I wanted to write a log, I would write to the Samurai API directly. Now, it would be a very sad and expensive day for my company to come and say, Samurai is too expensive, we need a different logging service. Every file on every service that I interacted with Samurai directly would have to be changed and tested. So that's an expensive day because a lot of developers are going to have to do some work to move away from Samurai. Now, pretend like we were being smart and planned ahead for a migration that may or may not have happened. I would have taken a mapper file or written a wrapper around the Samurai's API. I would allow it to interact with the API and use all the features that I possibly could, but I would make it generic and I wouldn't make it specific to Samurai. That way, I can use that file or library anywhere in my code. Then when the day comes that my company decides Samurai is an expensive thing, there's only one file or a group of files, very few of them, that I would have to change. You can even take this mapper file and make it talk to several different kinds of APIs based on the environment that it's in, or different feature switches or environment variables. We call this an encapsulation or an abstraction of the interface. Okay, so let's take this idea as far as we can. If I'm building a service, let's call it a feature switch service, I can safely assume that there are people who are going to want to use my service, and I'm going to have to talk to a data store and potentially other parts of the service as well. I could build this service with a single file that handles all the ins and outs of the feature switch service. A request comes in, I check the database, and I spit out an answer. All of that logic would make sense to be in one place. At least, I hope you're able to identify that this isn't really a great idea. So let's try to identify some of the interfaces of this service. I have a client that needs to talk to me. I need to talk to a data service, and there's some business logic that I have to know in order to give a valid answer about the feature switch. So when I am working on a service with, safely grouped functionality, like a feature switch service, I create at least 3 files. One, I call it a routes or a resource file that defines the endpoints or the ways that other clients can talk to my service. I create another file called the service file, which has all of the business logic and is really the brains of the operation. And I have a data mapper, which would actually map the talking to the database. I call the second file a service file, but it tends to get confused between the service, which is the business logic, and the whole service, which is the server running on the service. Server, service, whatever. If you have a better idea of what I should call this file, I am all ears. I want to hear what you have to say in the comments. Okay, so the routes file is dependent on the service file, and the service file doesn't know anything about the routes file. The service file does depend on the data file or data mapper file, and the data mapper doesn't know anything about the service file. The data mapper talks directly to the database, and that's where I usually store my database queries, is in that file. How does having 3 separate files mitigate migration issues? Well, if we take this feature switch service with the 3 files that we created and then try to switch out 1 or 2 of the services that we interact with, then I think you'll get the idea. So my company could come along and say, we want to support a new protocol. So I originally wrote the feature switch to support HTTP REST calls, which is the get, put, post requests, generally available in most APIs. But they want to support this new hotness called gRPC. Well, in order to support this, I don't have to change most of my server's code. All I have to change is the routes file. I don't even have to replace the routes file. I could write a new routes file and call it routes gRPC, have it support the gRPC protocol, and talk to the service file. Organizing and encapsulating my code that way makes it so that the HTTP routes and the gRPC routes can talk to my service and return the same data. Now, these routes files are responsible for translating the incoming data into a format that my service can understand, but that is a lot less code that has to sit on the Edge API. I don't have to re-implement it for every single type of protocol that I want to support. Same thing can happen if we decide as an engineering team that we no longer want to talk to a MySQL database. Let's say we want to switch to Postgres or MongoDB, I don't know. All I'd have to do is update the mapper file to support the database that I want it to use. If I want to support both the old database and the new database, no big deal. The data mapper is where I would do it. I have found that organizing my code in this way has helped with mitigating migrations, it's helped with knowing where to put my code, and it's prevented me from duplicating code and overall makes the migrations a whole lot easier. I hope that this was helpful for you. If it was, please like and subscribe the video and share it with any of your other engineering friends, and I'll see you next time.